Welcome to the Ed Outreach Day volunteer training presentation online. Part E will provide an overview of the water chemistry station, where students will gather data on chemical and physical parameters of water quality. The physical and chemical parameters at use in this segment include the following. Temperature, defined as the average amount of heat energy present in the molecules of a substance. The temperature of an aquatic system can be affected by many things, and the organisms that live there can be affected by changes in the temperature as well. Turbidity is the measurement of how cloudy or turbid a substance is. pH is a quantitative measure of the acidity or alkalinity of a substance, whether it's an acid or a base. It's worth noting that the water samples used in this activity are simulated and are prepared to have different characteristics that support the activity. Turbidity is cloudiness caused by the presence of suspended particles, usually too small to be seen by the naked eye. It can be caused by a number of things. Temporarily suspended fine sediment, or particles that will fall out of suspension eventually and settle to the bottom. Even smaller particles that will not settle out due to their small size. Or microscopic organisms, like plankton. Measuring turbidity doesn't tell you what's in the water, it only tells you that something is in the water that interferes with the passage of light. It can be measured using a kit that compares water samples to a standard turbidity solution, by electronic means using a turbidity meter that automatically analyzes light penetration, or by using a Secchi disc, a black and white marker that allows turbidity to be observed by eye and calculated according to depth. This is the method we'll use today.
You'll receive the script ahead of time. The point of this station is to compare the temperature, pH, and turbidity of the two samples. Divide your group in half and have one subgroup work on pH and temperature, and the other group work on turbidity. One way that scientists measure turbidity is to use Secchi discs. To take a reading, slowly lower the Secchi disc until you can no longer see it from above. Note the marking just above the water level. Count the watermarks below it and record the results. Repeat this with the second sample.
You're probably familiar with pH. pH is a measure of the acidity or alkalinity of a solution. This pH scale uses the word basic instead of alkaline, but they mean the same thing. Technically, pH is the measure of hydrogen ion concentration in any solution. And the higher the concentration, the more acidic a solution is, and the lower the pH. Why lower? Because the pH scale is calculated as the negative logarithm of the hydrogen ion concentration in moles per liter. In simple terms, the calculation of pH allows for a vast number of different concentrations to be illustrated on a relatively simple scale. Sulfuric acid at pH 1 is 10 times more acidic than lemon juice with a pH of 2, and 100 times more acidic than orange juice with a pH of 3, and so on. pH in surface water can be affected by naturally occurring conditions, such as the type of rock over which the water flows. Limestone, for example, is an alkaline mineral that tends to have a neutralizing effect on acidic water. The presence of dead and decaying organic matter can have an impact on pH as well, as one of the products of decomposition is carbon dioxide. Adding carbon dioxide to the water makes it more acidic, as the carbon dioxide tends to form carbonic acid in water. The presence of photosynthesizing organisms, like phytoplankton, can also have an impact on pH. As the rate of photosynthesis changes from day to night, the chemical makeup of the water, including the dissolved gases, can fluctuate. More dissolved carbon dioxide is used up during the daylight hours by plankton. This has the tendency to make the water less acidic during the daylight. Human impacts on the pH of surface water can be substantial. Historically, industrial discharges of waste have contributed to water pollution. These are largely regulated by the government and are for the most part a bit less of an issue than they were in decades past. Emissions from combustion engines can also contribute to a depression of rainwater pH. Sulfur dioxides and nitrogen oxides from the burning of fossil fuels combines with water in the atmosphere to form sulfuric and nitric acid, falling to Earth as acid rain or snow. In southwestern Pennsylvania, acid rain is less of a threat because of the amount of alkaline limestone found. Instead, the greater threat is caused by the discharge from abandoned coal mines. When coal mines are no longer pumped out, they fill with water. The water can leach sulfur-laden iron sulfide minerals out of the ground, and when they're exposed to air, those minerals oxidize into an acid. Orange iron precipitates out of the well, fouling all kinds of aquatic life.
In addition to measuring temperature, students will also determine the pH for each sample. To do this, ask the students to fill the tube with 10 milliliters of lake water. Add 10 drops of indicator solution, cap it tightly, and mix. Place the tube in the holder and use the color bars to determine the pH. It may be helpful to hold the unit against a white background.
Recording data. This is the most often overlooked aspect of the activity when students become engaged with the materials. Remind them often, scientists record their observations so that they can be shared and communicated and ultimately used by others. Some of the teachers that will be accompanying your students will actually collect the logbooks and use them as part of their daily grade. We do encourage the students and the teachers to take the logbooks with them at the conclusion of the activity for use later at school. Interacting with students. Assist students with instructions as needed, including how the different test results are interpreted. Some students will be stronger technical readers than others, and some may benefit from some extra guidance on following a checklist of instructions. Facilitate comparisons of the results at the station. How might electronic meters figure into a process like this? Is there a value in repeating a testing procedure? Help students consider what their different test results might mean in the context of the two bodies of water. Why is one warmer? Why is one more or less turbid? And so on. To review, the physical and chemical parameters considered in this program segment include temperature, the average amount of heat energy contained by a substance, pH, the measure of acidity of a solution, and turbidity, or relative cloudiness of a sample. Differences in these parameters can have natural causes and can sometimes be traced to human activity. Please direct any questions about your work as a volunteer for Ed Outreach Day to Barbara Leese at barbara.leese@aiu3.net.